We're now going to use the unit circle to define the trigonometric functions. And this is going to be very important for calculus because calculus involves unit circle trigonometry, not right triangle trigonometry. And here's how we're going to define it. This is actually very, very simple. It's really kind of neat. So here's our unit circle. And we take this positive x-axis and it rotates at the origin and it spins around the unit circle. Okay? And wherever it stops on the unit circle, it stops at an ordered pair that's on the unit circle. Okay? And what we do is we define the cosine of that angle, wherever it stops, that's the angle, theta. We define that to be the x-coordinate on the unit circle. Okay, we defined the sine of theta to equal the y-coordinate on the unit circle. And we defined the tangent of theta to just be y over x. Okay, so one way to think about this is that the cosine theta is kind of the horizontal component of this point, right? It's that x-coordinate, wherever the x-coordinate is. The y, the sine of theta is the y. That's the vertical component of the point as it goes up and down. Now the tangent of theta, this is interesting. If you consider the origin here, then there's a line, right, going through 0, 0, and xy. Well, the slope of that line, which would be the slope of the radius as it spins around, when you stop, the slope of this line will be the difference in y over the difference in x, which is just y minus 0 over x minus 0, or just y over x. So that means the tangent of theta, the tangent of your angle, is just the slope of that radius wherever it stops. Okay? So this is kind of the horizontal component, the vertical up and down component. This is the slope of the line as it goes around. Okay? And then we also include three other trigonometric functions, and they are just the reciprocals of each of these. So the reciprocals of this cosine theta is the secant of theta. So that's just equal to 1 over x. And then the reciprocal of the cosine theta is the cosecant of theta, which is 1 over y. And then the reciprocal of the tangent of theta is the cotangent of theta, which is equal to x over y. So each of these are just the reciprocal of each of those. So, and the way that I remember these is I just remember that the tangent and cotangent go together, okay, but the cosine and the cosecant don't go together, okay. The sine and the cosecant go together, and the cosine and the secant go together. And so basically, each one of these pairs has a co and a regular function. So secant, cosecant, sine, secant, cosine, sine, cosecant, tangent, cotangent. Okay? So, those are the basic trig functions. And so, to actually evaluate the trig functions, we can do it for quite a few points that are on the unit circle. So let me get our special points thing that we made. So for all these angles, all these radians around the unit circle, I can actually evaluate these functions. So for example, like cosine of pi over 3 would just be the x-coordinate, which is just 1/2. Okay? And so let me write that down. Cosine of pi over 3. And you know, the way that I think about these is in my mind I actually draw a unit circle, and then I think of that as being like this 60-degree angle. And for cosine I drop it down and I notice that has to be the 1/2. Okay? So for this point the x-coordinate is the 1/2, and then when I bring this over to the y-axis, that's the square root of 3 over 2. So this would make this 1/2. Okay? Let's try another one. Let me do, we'll say sine of 5 pi over 3. Okay? And I want to evaluate this. So in my mind, I just think, oh, 5 pi over 3. Okay, there's 6 pi's over 3 around the circle. That means I'm backing up 1, and I'm right here. And then when I move that over to my y-axis, the y-coordinate is negative square root of 3 over 2. Right? The x-coordinate is a positive 1/2. So this would be negative square root of 3 over 2. Okay? So a little diagram like this can help quite a bit. It can help you evaluate these. I always liked, if I had, like, let's say a cosine of 3 pi over 4, I always liked the pi over 4 because I knew both the sine and the cosine was square root of 2 over 2. I just needed to know whether it was positive or negative. And so for, like, cosine of 3 pi over 4, I just know we got 1, 2, 3 pi over 4 is over in this quadrant, the second quadrant, and so that means the sine is that means it's a negative value. So this is negative square root of 2 over 2. And I don't even really need to draw a diagram there. What about like tangent of, we'll just say, let me just say like tangent of 7 pi over 6. Okay? Now this one, I really want to take some care here. I would probably draw a diagram, and then I know we got 6 pi's over 6, and the 7 pi over 6 would be down here, and then I know that the x-coordinate here is negative square root of 3 over 2, and then the y-coordinate comes over here, and it's negative 1/2. So I know that they're both negative here, and then I know that the tangent of 7 pi over 6 would be the y over the x, like this. And so what I need to do here is I need to invert and multiply. So I get negative 1/2 times negative 2 over the square root of 3. And then I see that these cancel out, right? And I get the negatives, 2 negatives make it positive, so I get 1 over the square root of 3. And then we always want to rationalize the denominator here. So I multiply the top and bottom by square root of 3, and I get the square root of 3 over 3. And that's kind of the official special value for tangent of 11 pi over 6. So let's try something like secant of, we'll say, 5 pi over 6. So let's try that. Well, 5 pi over 6 would be this one. You got 6 of them, back up 1. And then the x-coordinate for this is negative square root of 3 over 2. The y would be 1/2. So here, the secant is 1 over the x. So this is 1 over negative square root of 3 over 2. And so then I'm going to invert here and multiply. This would be negative 2 over square root of 3. Then multiply the top and bottom by the square root of 3 to rationalize the denominator. And I get negative 2 square root of 3 over 3. And that would be kind of the official value for that. And then let me try another one here. Let's say I have cosecant of I'll say cosecant of 7 pi. Okay, well, 7 pi is multiple times around the circle. So here's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi is over here. And I see that this would be, negative 1 for my x and 0 for my y. Now the cosecant is 1 over the y, so this would be 1 over 0, and you can't do this. You can't divide by 0. That's undefined. So this one here is undefined. Okay? So some of the trig functions can be undefined. Any ones that have an x or a y in the denominator. So tangent, secant, cotangent, all have places where they're undefined, and it's where the denominator is equal to 0, which is going to happen at one of these quadrants, right? And that's why this one here happened at that quadrant over there. So, really, with just a little bit of understanding of this unit circle, you can do a lot of trig values. Okay, you can do all these. You can spin around several times and stop at one of these angles that are coterminal. You can do the negative ones in this direction. And really, you just have a little bit of memorization as well as adjusting for signs. And then you can get a lot of trig values, even just from, not just solely from memory, but by drawing a little diagram and constructing it from your understanding of the unit circle. And that's great practice. And oftentimes problems involve these, especially in textbooks, as you're learning how the unit circle works. You're going to get problems that involve these trigonometric values. Okay? And so you really want to practice these. And what I did is I found an app that I was able to embed in the page with these trig videos. So if you go to the bottom of the page, there's an app, and they're like flashcards, and they'll give you these values, and then you gotta find they'll give you like secant, or no, actually it's just these. It only works on these, so it'll say like sine of 5 pi over 6, and you gotta figure it out, and you click on the card, it'll flip it over, and you can see if you got the right answer. And so it'll give you a chance to practice these values. I would encourage you to go through them at least once and see how you do on that. Now let me tell you, sometimes, like when the app originally came up for me, it actually gave you these values, like negative square root of 2 over 2, and it was asking you for the trig function, kind of like Jeopardy, which isn't quite what I wanted. You can change it so that it gives you this and ask for this value, and the way you do that is hit options, and then you say answer with definition. You got to change it from term to definition, I think, and then it'll allow you to do that. And so give those a try. That's a nice feature. And there's some other little games, like there's one where they give you a bunch of, kind of like a mahjong thing, but you pair them up and then you click on them and they disappear, and you got to see how fast you can get all the little tiles to disappear. So great stuff there to practice. Now let me tell you, if your point is not, if your angle is not one of those angles on the unit circle, then the way that you're going to evaluate the trig function, you can't just derive it algebraically or whatever. You're going to need a calculator to do that. And let me tell you one of the most important things when doing trigonometry with a calculator. And forgetting this, it can be one of the most aggravating things as a trig student or as a Calc 1 student. What you got to remember is you have to make sure the mode, so go to mode, you have to make sure the mode of the calculator is in radians. So it can be in radians or degrees. So you could be trying to solve a problem, and you might have it in degrees, but you're trying to find the radian or whatever, and it just does not come out right. The answer won't make any sense, and it's because you have your degrees and radians mixed up. So you want to put this on radians, right? And so if you remember, all the way around the circle is 2 pi radians, and so 5, this was here, if you remember, this here was like 3 pi over 2, so this is like 4.71 or something. So let's actually find the cosine of just 5, okay? So if I just want to do like the cosine of 5, that's going to be a point down here. 5 is a little bit past 4.71, so it's going to be somewhere over here, and the x-coordinate, so somewhere close to 0. And there you go, like 2.83. That's pretty good. And if I did sine of 5, oh, sorry about that. Let's see. If I did sine of 5, well, this would be the sine coordinate, and this would be close to -1. So let's click it, and there you go, -0.9589. It is close to -1. And so any other angle, even if it involves a pi, so let's say I want to do cosine of, let's say, 5 pi over 11 or something like that. Okay, some weird angle. I'm going to need my calculator to find the trig value for that. So if it's not a special point on the unit circle, then you need to use the calculator. Now if you want to do a secant, if I want to find like the secant of an angle, so let's say I want to find the secant of 5, then the secant is the cosine, so I need to do 1 divided by the cosine, 1 divided by, and then do cosine of 5. So don't do the cosine inverse. I did the wrong thing there. The cosine inverse is when you want to find the angle that gives you a trig value. Okay, and that's different. That's the inverse function. Okay, and we'll look at that when we solve trig equations here in a minute. Okay, so there you go. That would be the secant of 5. Okay, and the secant of 5 is 1 over the cosine of 5. Okay, so that gives you the definition in terms of the unit circle. I want to show you one last thing here, and that is, when you first learned trig, you probably learned this definition. This is right triangle trig, and it's where you have a right triangle, and then you have an angle in your right triangle, and once you determine the angle you're interested in, the side that was opposite of that, that's known as the opposite side. This is the adjacent side, and then the long side opposite the right angle is the hypotenuse. And so we define sine of theta as the opposite over hypotenuse, the cosine of theta as adjacent over hypotenuse, and the tangent of theta as the opposite over adjacent. And you maybe learn this by saying like SOHCAHTOA, right? SOHCAHTOA. Now I struggled with this. I couldn't remember how to spell this, and I'd mix it up. So SOHCAHTOA wasn't very helpful to me, but what I learned was some old horse, right? Some old horse came a hopping through our alley. Okay, so sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Some old horse came hopping through our alley. That's how I memorized it. That's what helped me. Now the really neat thing is, when we define this in terms of the unit circle, we actually get, at least for that, we get the same trig values as you would get defining it in a right triangle. So notice the angle here, it can't be 0, but it could be slightly more than 0. The reason it can't be 0 is you wouldn't get a triangle, okay? And it can't be exactly 90 degrees, because then you wouldn't get a triangle either. So it has to be, for right triangle trig, it has to be between 0 degrees and 90 degrees. And this is interval notation, not including 0 and 90. So here 0 and 90, like 0 degrees, 90 degrees. This is like the first quadrant here. And so notice, if you get a point here in the first quadrant, right, x, y, then I could drop this down and I get a right triangle, okay? And then the opposite side, and this is my theta, right? The opposite side is the y coordinate, okay, the height of that. So this is the y coordinate. This adjacent side is the x coordinate. And then the radius on the unit circle here, the radius is just 1, right? So if I use this definition, notice what happens. So the opposite over hypotenuse, the opposite is y, the hypotenuse is 1. So this would be y over 1, and that would just give me the y coordinate on the unit circle. Okay, adjacent over hypotenuse, this would be the adjacent side, x over 1, the hypotenuse is 1, and that would give me the x coordinate on the unit circle. And then the tangent would be the opposite over the adjacent, so it would be y over x. And that's just equal to y over x, right? But the point here is that this is the exact same thing that you would get if you use the definition, if you define the functions in terms of the unit circle. So from 0 to 90 degrees, the sine of theta is equal to y, or the cosine is equal to x, sine is equal to y, tangent is equal to y over x. So in other words, it doesn't matter if you define it in terms of the unit circle or right triangle trig, it gives you the same values. It'll give you the same values either way. So it's really equivalent definitions. It's only that the unit circle definition is involving, you can put in any angle because you can rotate this around and you can keep doing it, and you can go as much as you want this direction. You can also go in the negative direction. And so the unit circle defines it in terms of all real numbers, and it involves this rotation, rotating things around. And a lot of things in science, like planets rotating around the sun, things like that. And you'll also see that this involves periodic behavior, which is behavior that repeats itself every so often. And a lot of things in science involve that sort of periodic behavior. So the unit circle definition really, really makes the trigonometry much more versatile. And we're definitely going to be using the unit circle throughout this course. Okay? So go ahead and try that app. Practice some of these. Make sure you can define these using the special angles from memory, and you have no problem with that. And then any other one you use your calculator to define. So, and in the next video then we'll start looking at the graphs of the trigonometric functions.